In this problem, we will write a unit test suite for this function. The function is called collect underperformers, and it takes a list of numbers and an integer. Here we have a partial unit test suite. It only has one test case and 3 tests, and our mission is to fill in the 2 missing tests here. A few things to note. We are importing unittest, the unit testing framework for Python, and we are importing the underperformers.py file that contains the collect underperformers function. We also have one test worked out for us, and we can use the template for that test to write the other 2 tests. There are 3 lines in test underperformers low threshold. The first calls the function and assigns the result of the function to a temporary variable called actual. In the second line, we define what result we would like collect underperformers to return. So what would this function return if it was working correctly? In our case, this is the empty list because 4, 5, and 6 are all above the threshold value. And finally, we use the unittest assert equal method to make sure that expected, what we hoped the function would return, and actual, what the function in fact returned, are equal. We can do the same thing with test underperformers high threshold. This time, we would like to test this function with a threshold so high that every single element in the list is an underperformer. One thing to remember is that each test method in this test case is only going to call collect underperformers once. We're going to call it with the same list, but this time we're going to set a threshold that is so high that all these numbers are underperformers. Okay, then we assign the return value of this function to our actual temporary variable. And we set an expected variable, which in our case is a list containing 4, 5, and 6 in the same order that we saw them in the original list, like so. Finally, we make sure that these are equal, and this is the test underperformers high threshold test. We have one more test to write, which is test underperformers mutation. In this test, we don't actually care what the function returns. We just care that the list we supply to it is not modified, is not mutated as a result of that function working on it. Okay, so we're going to have a call to collect underperformers with a list and a threshold. Because this list needs to stay the same before and after the function is called, we are going to initialize the list here. We're going to have a list like this with 4, 5, and 8, and we're going to call collect underperformers on the actual list. We're going to set a threshold that makes 2 of these numbers underperformers, let's say 7, and we're going to have an expected value, which is going to be the same as our actual value. In this case, what collect underperformers does is not our concern. Remember, these are unit tests, which means that each one is only responsible for testing a small aspect of the original function. In the case of test underperformers mutation, we are only concerned with whether the list we give to the function remains the same after the function has run. And so at the end, we are going to make sure that is the case. Having finished these 3 tests, let's go back and implement underperformers. We're going to have a result list, which starts out being empty, and for every number in the nums list, if that number is strictly less than our threshold value, we are going to append that number to the result list. Done. We go back to test underperformers, and we run the test suite. It looks like we are returning none in 2 of the 3 cases, and that's a problem. We failed test underperformers high threshold and test underperformers low threshold, but we have passed the mutation test case. Okay, so we forgot to return result list. That will help. Okay, now let's look at the output. let's look at the output of the test suite. This line here tells us how many tests were run, there's a character for each test, and how many of them passed, that's the dot, and how many failed, that's the F. And we are told what the assertion error is. None is the result we achieved, 4, 5, and 6 is the result we were supposed to get, actual does not equal expected. Having fixed this, we can run this again, and all 3 tests have now passed.